Hey, there's Mr. Herm back with another video. This one's going to be on, again, composite areas. It's for this week that we're working on now. We're going to have 3 videos for this. This is the second one. And I suggest you watch all 3 of these and work it out along with me the best you can to follow along and see how I'm getting these. So in this particular one, we have quite a few shapes here. You could do this a lot of different ways, but I'm thinking I'm probably going to say, first of all, I need to find, again, the perimeter and the area. So the perimeter is more complex on this one than the last one, mainly because we have to find this curved area. Not curved, I'm sorry, curved distance here, this curved distance. We'll find the area also in a minute. So to find this, this is really just the diameter of this circle that is not here, the whole circle that's not showing, but it's only half of that. So it's only half of that diameter. So that's one thing we're going to keep in mind there. Plus, we need to find this part right here, which is, again, let's look at introducing a right triangle here. We know that this radius is 20 centimeters from here to here, which means this whole thing here is, that's your cue to answer, there you go, 40 centimeters. It's double that because it's the diameter. So we're going to need that too, so we know that that is 40 there. I also know that if I take this entire 80 here and subtract the 50, I get 30 right here. So that's 30 for this little bit to right here. So that's the triangle. So we can use our Pythagorean theorem again. We can also recognize that this really is a 3, 4, 5 right triangle, like in that last one we talked about before in class 2. 3, 4, 5 right triangle means this is times 10, that's times 10. That's going to be 50. I'm going to work it out anyway just to show you that prove that, but it will be. So we get 30 squared plus 40 squared equals c squared. And that's going to be 900 plus 1600 equals c squared. Add them together, we get 2500 equals c squared. And again, take that square root, which is the half power. So just hit caret, caret 0.5 with that in your calculator, not with the square root with it, not that, it's just this. And that'll give us the 50. So this is 50 here. So now I can probably find the whole distance around it now, the perimeter. So let's start with this top 50. So 50 plus 50. So I got 50 plus 50 as my P there for perimeter. That's these two 50s here. Then I got to go 80 for the whole thing. You can go 30 and 50, but I'm just going to go 80. Then for the tricky part, now we got to find this distance here. So this is going to be half the circumference. Remember, the circumference is pi times the diameter. But it's going to be half that because it's not the whole distance. It's only halfway around the circle. So we're going to say plus 1/2. This is 40. So 40 times 3.14. So we can figure this part out pretty easily here. This is 180 right here. And now we're going to use a calculator for the other part. Again, a little bit tricky on the reflections there. Try and get it to show up there better, I hope. Maybe just a little bit. Let's see how it looks. I get to work. It's not too bad. Yeah, that's pretty good. So we got 1/2 times 40 times 3.14. So 0.5 is my 1/2 times 40 times 3.14. Again, it's half. It's only half the circle. That's 62.8. So 62.8. And then you're going to add these together. So add that plus 180. Plus 180. That gives us 242.8. 242.8. And that's going to be in centimeters. Remember, it's not squared because that's just the distance around. Now we're going to find the area. I'm going to try and switch this up just a little bit and see if we can get a little more space here for the area now. So the area is going to be a little bit, maybe a little more complex almost, because we have to take the triangle. Or, you know what we could do is maybe just take this trapezoid right here. That is a trapezoid. Take the trapezoid and subtract the half circle. That'd probably be easy. Let's do that. So we'll take the trapezoid and subtract the half circle. So the trapezoid has a base of 80 and 50. Remember, the trapezoids have 2 bases. So trapezoid's formula is 1/2 times 80 plus 50 times the height, which is 40. And then we have to subtract that half circle. So 1/2 pi r squared. And the radius is 20. So let's put in this part first. Try and sneak it over here so you can see me doing it. Maybe it'll help a little bit with your calculations. Not the best view of it there, but it's something. That's a little better over there. Okay. So I'm going to take the 0.5, the parenthesis. I'm doing this part right here right now. So 0.5, And then I've got 80 plus 50. And then I've got outside there times 40. That comes to 2,600. And then after that, we got this part here. That seems awful high to me. 130. Yeah, that's right. That is right, isn't it, I guess? Yeah. 130 times would be 1,300. Hold on. I feel like that's not right. Did I miss something up there? Let's double check that. So I'm going to take 80. Just don't believe it. For some reason, my mind's playing tricks on me. So 80 plus 50 is 130. Take half that times 0.5. And they take that times 40. Times 40. Oh, yeah, sure enough, it is 2,600. So I was wrong. So let's continue going here. Now we're on to this one. So we're going to put this whole thing in the calculator here. 0.5 times 3.14 times 20. And then hit the x squared button or the caret 2. 628. Now let's go ahead and subtract those two things. 2,600 minus 628, and we get 1972. I was 1 year old that year. Look at that, long time ago. 1972, and that's going to be centimeters squared. All right, stay tuned for the next video, which is going to be, again, another composite figure. Have a good one.